Want to solve the initial value problem, y double prime minus 4y equals 2e to the t plus 1, y of 0 equals 3, and y prime of 0 equals minus 1. This is going to be solved by undetermined coefficients, but first we need to do the homogeneous problem. The characteristic equation for this is r squared minus 4 equals 0, so our roots are at plus or minus 2, means this general solution is c1 e to the 2t plus c2 e to the minus 2t. Now for the non-homogeneous part, we're going to guess a solution of the form a e to the t plus b. We've got a polynomial here of degree 0, so it's just a constant, so I have to put a constant there. And I've got e to the t here, so I have to guess a e to the t. Since neither e to the t nor constants solve the homogeneous problem, that's a good idea for our guess. Differentiate this then, we get that y prime should be a e to the t plus 0 because the b goes away. Y double prime is also a e to the t. And we can plug this in. So y double prime minus 4y should equal a e to the t minus 4 times a e to the t plus b, which is negative 3 a e to the t minus 4b. And I want this to match 2 e to the t plus 1. So to make that happen, I need to choose a to be negative 2/3 and b to be minus 1/4. This means that yp will be negative 2/3 e to the t minus 1/4. And so therefore my full general solution will be y of t is negative 2/3 e to the t minus 1/4, and then plus c1 e to the 2t plus c2 e to the minus 2t. And now I should worry about the initial conditions. So we were given values for y of 0 and y prime of 0. We want y of 0 to be 3 and y prime of 0 to be minus 1. Y of 0 plugging in above is negative 2/3 minus 1/4 plus c1 plus c2. And y prime of 0, I'll still get the negative 2/3 because that'll still be e to the t. The 1/4 goes away. This gets me a plus 2 c1 and a minus 2 c2. Now I can rearrange things a little bit to get that I will have 3 plus 2/3 plus 1/4 equals c1 plus c2. And then negative 1 plus 2/3 equals 2c1 minus 2c. This will be a 3 out of 12. This will be an 8 out of 12. And 3 is 36. So 36 plus 11 is a 47 over 12 here. This becomes a negative 1/3. I'm going to double the first equation and then add them to get rid of the c2s. If I do that, I will get 47 over 6 minus 1/3 should equal 4c1. This becomes a 45 over 6 or a 15 halves equaling 4c1, which tells me that c1 must be 15 over 8. Using the second equation here, which will tell me that negative 1/3 should equal 15 over 4 minus 2c2, tells me that 2c2 is going to be 15 over 4 plus 1/3, 49 over 12. Then dividing by 2 tells me that c2 should be 49 over 24, just bigger than 2. So then my initial value problem solution is negative 2/3 e to the t minus 1/4 plus 15 over 8 e to the 2t plus 49 over 24 e to the minus 2. That's how you solve and work out this entire initial value problem using the method of undetermined coefficients for finding the general solution for the non-homogeneous second order equation.